Vertex BD is an extremely powerful tool for automating architectural drawing sets, production drawings, material reports, and manufacturing. It can even be used to create marketing renderings and videos. Production home builders are using our automatic house option system to automate architectural and permit sets based on home buyers' option selections. The base model and all available options are set up in a master model like this. Then when a home buyer selects this house and chooses their options, Vertex BD automatically merges together the selected options and updates all the layouts, elevations, and section drawings, saving hours of drafting time. Component manufacturers, modular builders, and even on-site stick framers are using Vertex BD's powerful framing system to automate framing layouts, shop drawings, cut lists, and manufacturing for both wood and cold form steel framing. I'm going to focus mainly on the framing features in this demo video. I'm going to start by creating a new project. So I'm going to go to File, New Project, and let's give this a name. Call it Framing Demo. And here you can enter in information about the project, customer name, location, so forth. A lot of that will end up on your drawing sheets and material reports. If you already have an architectural design done, you can bring in the layout by referencing in a DWG file and tracing over it. If you have a 3D model created in another BIM software, you can import an IFC file and then convert the objects into vertex objects. For this demo, I'm just going to draw a layout from scratch. So we'll start with the add wall function. In here, we have some standard wall types already set up for 2x4, 2x6, 2x8, exterior, interior, bearing, and non-bearing walls. Each wall, you can set up different layers. So what kind of exterior finish material, what kind of sheathing, the framing, and interior sheathing. You can also add additional layers if you need to do multiple layers of sheathing or layers for strapping and insulation. Each layer also can have a set of rules on how it's going to generate parts. In our default installation, we have framing tools assigned to the main frame layer as well as the exterior sheathing layer. If I take a look at the framing tool for the frame layer, I can see the rules on how this layer is going to generate parts. Here we can control things like how it's going to frame out the corners, T-intersections, free ends and end-to-end panel seams. You can also assign a tolerance value for the panel seams, the material used for on-center studs, and quantities if you need to use a single, double, or triple on-center stud. You can even have a different material for the sheathing seam, the on-center stud spacing, how the spacing is measured, whether it's from the right end of the panel, left end of the panel, center, from both ends working towards the middle, or free will evenly space the studs. We also have this checkbox. If you model trusses, you can have it automatically add studs under the trusses. We have an option if you choose the center start, if you want to double up the number of studs on the center. We can choose from a number of details for the top and bottom plates and the materials that are being used in those assemblies. Horizontal blocking or end blocking, we'll just add blocking in the first and last stud bay of the panel. Blocking can either be flat, normal, or on edge against the interior, exterior, or both sides of the wall. And then openings have 3 sets of rules based on the width of the opening. So for wider openings, you can have it automatically adjust the framing. So in this case, openings up to 48 inches wide will get 1 jack, 1 king. Openings wider than 48 up to 96 inches wide will get 1 jack, 2 kings. And then wider openings will get 1 jack, 3 kings. You can customize these rules as needed. You can also change the size of the header material and the header detail that's being used, whether it's a header along the top plate or something along the top of the opening. You can also choose the sill material and number of sills, as well as the cripple material. If you're exporting the framing to an automated saw that has drilling or routing capabilities, you can set up rules for how it's going to drill holes in the bottom plate for anchor bolts, and you can set up service hole heights and diameters for electrical and plumbing, for example. I'll select this 2x6 exterior bearing wall, click OK, snap to the origin marker, then I can right click and choose this rectangular wall shortcut, which allows me to quickly create a rectangular layout. Now I can just type in distances for how far I want to go in the horizontal and vertical directions. So let's say I want to go 40 feet in the X direction, then comma, I'll go 24 feet in the Y direction, and then enter. Now I can continue and add additional walls. I'm going to right click again. Let's turn off the toggle open closed wall. That also turns off the rectangular wall. And then we can select the index card to select another wall from the wall library. We'll go into the interior wall library, select framed walls, and let's go with a 2x6 interior bearing. I can also right click and choose the center line as my reference line and snap that to the center point of the side wall, lock in horizontal, and snap to the other end. Again, I'll right click, select a different wall, and let's throw in some 2x4 interior non-bearings. If I want to measure a distance over, I can hold my cursor over the point that I want to measure from, hit Q, then U on the keyboard will lock me in the horizontal direction, and then just type in the distance. So let's say I want to go over 12 feet. I'll just type in 12 apostrophe for feet, and then enter. So that selects the first point of the wall. Now I can hit I in the keyboard to lock in vertical, and then snap to the wall above. I'll just draw a couple more interior walls here. And then escape. And if I hit F2, I can take a look at the 3D model, and I see that it creates the 2D and 3D at the same time. Hit F2 again to go back to 2D. If I want to edit this layout, I can just select a wall, click on the grab point, constrain in the horizontal direction, or whatever direction you want to go in, and then just type in the distance. So let's say I want to move this wall to the right 24 inches. I just type in 24, enter. The wall moves, and notice how it maintains connections on the corners and T-intersections. So it makes it easy for editing layouts. You can also break those connections. If I select the wall, I can right-click on that endpoint and disconnect wall end. So that'll allow me to move that wall end freely if I didn't want to maintain that connection. Now I'll go to the add window function and throw in some windows. So we have some standard examples of different manufacturers. Framers just generally like to have a simplified window model so you don't have to worry about the different styles and grill patterns and so forth. So you can turn off the different libraries and just have a simplified selection of rough opening sizes. I'll select the wall that I want to add it to, and again I can right click and choose what point I want to use as my reference, and then I can measure the same way I did before. So I'll just Q on the point that I want to measure from, and then move my cursor in the direction I want to go and type in the distance. So let's do 6 feet here. And then I'm just going to pick a couple of random points just to do this quickly. So I can hit confirm, which is pressing down on the mouse wheel, and then that lets me select the next wall. And then I can go to add door and do the same thing. Let's add something a little more interesting. And doors, if I right click, we can mirror, so it's left hand, right hand, and then we can flip whether it swings in or out. And I'll select the next wall. And if I want to select a different door, I can right click and hit the index card. And that takes me back to the selection dialog. I'll hit the back arrow at the top so I can pick a different size from that folder, or I can just pick from a different folder. So let's go down to the interiors, and I'll add some cased openings here. So let's pick 3.0. And again, I'll just pick some random points here just to fill this in quickly. And we'll throw in a patio door right there. So again, if I hit F2, I can see all my openings. Before we start generating wall framing, there's a few more things we can do to prepare the layout. Let's say, for example, we have a beam running across and we need to add a stud pack to support it. We can go to the Wall Panel menu and select Wall Panel Layout Accessories. And in here we have a number of different types of assemblies that we can add to the layout. Things like beam pockets, extra backers, ladder blocking for like cabinet backing and so forth, various stud assemblies, extra studs, another form of ladder backers. This one adds end studs to it as well. We have macros for doing panel breaks. You can also specify part of the wall that's going to have different on-center stud spacing. Stud bay assemblies will reserve a space. So for example, if you have a pipe or something coming up the wall and you want to make sure it doesn't collide with the non-center stud, you can use this to reserve that space and add studs on either side of it. And we have this macro for doing cross bracing or just single diagonal bracing. I'll select extra studs to floor plan. Then I'll click the wall that I'm going to add this to. This just gets the default value of the stud material, but I can just change it by hitting the select button and selecting a different size from the profile library. Or I can go to a different profile library if I need to pick a different grade or species of lumber, or we have other materials like LVL, PSL, I-beams, and so forth. In this case, I'll just pick a 6x6. You can select a quantity, if it's going to be centered on the wall or against the interior exterior side of the wall, and if it's going to be rotated. In this case, it's just a 6x6, so it's going to fill the wall on the center, so I don't have to worry about those. I'll just click OK, and now I locate this macro just like a door or a window. So I'll just click a point here, confirm, and then I can click another wall and then line it up with the original and do the same. So I know that these three will line up vertically through the layout. And when I start generating parts, I know I'm going to get that 6x6 right at those locations. Another thing we can do is put special framing on individual openings. So for example, on this wall, I have these two windows that have the same width, so they're going to get the same framing based on the framing tool of the wall. But if there's a situation where one of these needs special framing, then we can go to the framing menu and select the special framing function. I'm going to select add new special framing. Again, I pick the wall to get the default values, and now I can change this. We can even give it a label. Select a different header detail, the header size. Let's pick an LVL. The sill quantity, and then the numbers of jacks and kings on the left and right side. So here you can actually set different values for the left and right side of the openings. Then I'll click OK, and then select the opening that I'm going to apply it to. So it even gives us a callout that shows some of our selections, and we have controls over what's going to be visible on that callout, so you can modify that. And if you need to apply the same rule to another window, I can just click another window. If panelizing, you can let Vertex automatically locate where those panel breaks are going to be based on general rules for the minimum and maximum panel lengths. We have those set down here in project parameters, and you can set different values for each level and for the different wall types. So for example, I'm on the first level and I have exterior bearing wall selected, and you can see my max is set to 192 inches, and then I also have preferred lengths. If you don't want Vertex to break the walls up into panels, then you can just select a large value, either 800 from the drop list, or type in something if you have longer walls than that, and set it for both the preferred and max lengths. And don't forget to do it for the interior bearings, interior non-bearings, and for each level of the building. The designer can also specify exactly where those panel breaks will occur using our panel break macro. So again, I can select the wall and then locate it just like a door or window. If I want to measure off of a point, I can do the same thing I did before. Hit Q, pull my cursor in the direction I want to go, and then type in the distance. So let's say I want to go 16 feet, enter, and then I can continue, move my cursor over, type in another 16 feet, and enter. Then I'll confirm, and then repeat on the next wall. So again, I'm just going to do this quickly and just select a couple of points. Doing it this way with the macro is nice because you can copy those from floor to floor, and then you're guaranteed to have those panel breaks line up as you go up the building. So to copy this up to another level, I can just box in the whole thing or hit Control A on the keyboard, right click, go to Advanced, and copy to another floor. Here I'm going to select the second level wall layout, and then we'll leave this active. And now I can modify the second floor layout. So for example, if I want to get rid of the doors and replace them with another window, I can select a window and copy, or pick one from the library. I already have the midpoint selected, and then I can center it over this door by snapping to that midpoint right there. And we can do the same on the back. So first I'll delete this door, and then copy this window over. Then let's switch back to the first level wall layout and start generating our panels. So we'll go to the wall panel menu, select Generate Panels. Here you can control things like what layers you're going to be generating, how the corners will lap, how the labels are numbered, as well as other details about how the panels are going to be generated. I'll just stick with the defaults and click OK. Hit Control A to select all the walls, and then confirm, which is pressing down on the mouse wheel, or V on the keyboard. Then I can go back to the wall panel menu and select Generate Parts, and again hit Control A and confirm. Then we can go to the second floor and do the same thing. When done, I'll hit Escape to end the function, F2 to look at the 3D model, and then we can switch to the framing model if we want to see all the framing parts. Now notice we also have this set up to do lapping double top plates, so it's holding back the double top plates and leaving a space for those lapping plates to be field installed. There's also control and project parameters where you can have those double top plates flush with the panel seams. We can also add additional components to the wall panels, such as hold downs, electrical boxes, and pipes. To add the hold downs, I'm going to switch to the 2D layout, go to the wall panel menu, select Framing Accessories, and in here I'll select the hold down anchors. This is from the anchors folder here in the browser. Select the component we want to add, click OK, and I need to select the panel and then the studs that the hold down will be connected to. So I'm going to hold down the control key and I'll just select a couple of studs here, confirm, and then you'll see the components come in on the layout. Hit escape, take a look at the framing model, and you'll see we have those components added into the framing model as well. And if I click on this bottom plate, you'll see that it actually punched a hole in it. So if we're sending these parts to a saw that has drilling or routing capabilities, it'll get that hole information and create the hole automatically. The electrical components are located in the component browser. Here you can choose from a number of 3D components as well as just 2D symbols if you just want to do a 2D electrical layout. But to add the items to the panel drawings, we can use these 3D electrical boxes. So for example, if I want to add a gang box for 2 switches, I'll select the wall, then I can right click, select the reference point, and snap to the stud. If I hit escape, take a look at the architectural model, you can see now I have my switch there, and in the framing model I have the gang box attached to the stud. The piping tools will allow you to add plumbing as well as HVAC ductwork. I'll select a pipe, so we can choose from copper, ABS, PEX, PVC, or you can create some new components in there as well. And you can choose the diameter that you need. I'm going to measure from the center of this bottom stud here. So I'll hit Q, lock in my vertical direction, and I'll pull this up 24 inches. And now I can lock in my horizontal, and I'll just stretch this pipe out all the way out to here. And then if I want to pull this down, I'll lock in the vertical direction, which was O in the keyboard. And I can stretch this straight down. I'll even just pull it down through the bottom plate here and confirm. And now I can generate the holes where that pipe ran through the studs. So again, under the pipe menu, I'll go to Generate Utility Holes. We can select which pipe type we want to select. In this case, I'll just click All. And then which panels we're going to be checking. And now you can see I have the holes added wherever that pipe intersected the stud. So again, that hole information will be passed to automated manufacturing equipment. If you have a wall panel line in your factory with automated nailing bridges and routing, you can generate that information in Vertex as well. I'll select all my wall panels and then run the NC Accessories function. This function can be set up with different rules for nail patterns, whether it's along sheathing seams, the edges, and within the sheet. Notice it also created these blue lines. These are the routing lines where the sheets need to be cut. We can also add glue lines as well. When the wall panels are complete, we can generate the shop drawings by going to the Output tab, select the Panel Drawings function, then I'll select all my panels by clicking on the first and last row while holding down the Shift key. Then I can right click and select Create. I'll pick a wall panel template drawing. You can customize those as well. If you want to add your company logo and other information to the template sheets, you can do that. Now I can hit Exit, save the project, We'll go to the 2D layout, select the panel label, and then we can click the open drawing function to take a look at this drawing. So you can see we got some automatic dimensions, part labels, the cut list for the framing, as well as for the sheathing. You can see this is the panel we added the hole downs to, as well as the electrical box. And this is the line for the pipe. We also get information about the panel, such as the panel height, the frame weight, and the panel weight, which is the frame plus the sheathing. We can also throw in a floor and create floor panels as well. I'm going to switch to the second level deck drawing. And we can draw the floor either in the 2D layout, or we can use the 3D model, which in this case is very simple since we have a nice rectangle. I'm going to right click, go to add floor. I'm going to select our default floor system, which is this 2x10. And again, it has framing tools as well, similar to the walls. So this is just set up to do 2x10 dimensional lumber with 16 inches on center, as well as a 3/4 inch tongue and groove OSB decking. I'll click OK, and now I'm going to right click, and if I was adding this in the 2D layout, we could use this add using points method where you just click the corner points, but in the 3D model I'm going to use add using walls, and then click on my second floor wall, right click, and then I can use this function for selecting the linked walls, so it automatically finds all the connected walls around the perimeter, and confirm, and there's my floor. I'll switch to the 2D layout, select the floor, so now you can see you have grips and grab points around the perimeter, so you can move the edges or corner points. You can also right click on one and add additional points if needed. I'm also going to use this add hole function, and let's throw in a hole here somewhere, like if we have a stairwell. And you can click multiple points around the hole or just two opposite corners to create a rectangle. I'll select the floor again, and now I'm going to select the panel break function to add a panel break through my floor system. I'll rotate that 90 degrees using the arrow on the keyboard, then right click, and I'm going to change this method so that I'm just using a single panel break instead of doing multiple panel breaks out of spacing. And locate that right on that center wall there. And escape. And now I can go to generate panels. And I'm going to just box in this whole area and confirm. We can set the numbering. Click OK. And so now it generated the panels as well as the parts and sheathing. So now I'm just going to select a panel by clicking on the label. And then we can do things to this like adjust the edge details. Up here we have this edges function. And let's say I want to change this side to use a triple. So I'm going to click this edge marker, right click, go to properties, and instead of using the default, I'll go to the user detail, hit the drop list, and let's change this to a header with triple pieces, and OK. I'll hit escape, and with the panel still selected, I can come up here and add additional framing lines. So now I can add things like a cut line, support line, blocking, and ladders. So if I do ladders, I have to select the start and end point of my ladder run. Then I can choose a detail. I'll just stick with the default on edge. And under parameters, I can set the spacing. Click OK. And in comes my ladder blocking. If I want to add a flush beam, I'll select this panel here. Go to the same lines function. Right click. This time I'm going to select add cut line. So I'll select the start and end point of my cut line. I'll just do it right under this sheathing seam. And now I can choose a detail, whether it's just a cut line with blocking, a cut line without blocking, but we also have these details for doing a selectable flush beam. So for example, if I want to do a triple beam, then I can go to parameters and select a different material. I'll just stick with the default. Click OK, and in comes my beam. Then I'm going to right click again and just refresh the parts here. So I'll hit regenerate parts, and that just retrims those joists. And if we switch and take a look at the framing model, we'll see now we have our framed floor. We can generate the shop drawings for the floor panels exactly the same as we did for the wall panels. So I'll go to the Output tab, select Panel Drawings, and then you can see I have now 2 floor panels with no drawing. So I'll just hold the Control key and select both of those. Right click, hit Create, select my floor panel template, click OK, and now I have shop drawings for those floor panels. So we can take a look at that drawing. I'll click on the label, click Open Drawing, and we'll see we have the shop drawing. Similar to the wall panels, we have parts labeled, automatic dimensions. This one even has an isometric view. We could add that to the wall panel template as well. We get the cut list of the framing material and the panel weight. We can also export all of our panel drawings using our PDF export. And we have some PDF sets already defined. Oh, I need to save my project, so I'll just click yes on that prompt. So here we have a couple of PDF sets already defined on what types of panels we want to group together, and if we want to do selected panels, I'll just do panels-all. And now it's just going to print them all right into one PDF file. So now I have a PDF file with 37 panel drawings. And that's saved inside our project, so we can just send that right off to the shop. You can find the PDF file later by right-clicking on the project name and selecting Open Project Folder. That'll open up your File Explorer right to where the project files are located, and the PDF will be in a subfolder called PDF. We can also set a manufacturing order using the panel stacking function. So again, on the Output tab, we have Auto Panel Stacking and Manual Panel Stacking. The manual function lets the designer pick the panels in the order that they want, one at a time. The automatic panel stacking function allows the designer to select groups of panels, and then it will automatically stack them based on parameters like your maximum stack height and maximum stack width. Once the stacks have been created, you can generate the stack drawings. And double-click on the stack drawing from the project document browser and see how the stack was created. And if you want to make any changes, you can go to the Edit Stack Data function. Here you can see which stack each panel is assigned to, as well as the position within the stack. Each panel gets a row number, a column, and a depth. If there was multiple panels within a row, they would have different column numbers with the same row number, as well as front to back position, you would have different depth numbers. If you want to reorder, you can just shift the numbers around, and we leave spaces between the values so that you can slip a number in between 10 and 20, for example. After making changes, you can just go back and refresh the stack drawings. Now that the panels have been stacked, we can plot the shop drawings in the stacking order by selecting one of the stack order PDF sets. Vertex also has some great tools for creating complicated roof layouts. I'm going to switch to our roof drawing model pair, activate the 3D model, and under the roof menu you can see we have a number of different standard roof shapes, but then we also have this roof generator, which is fantastic for those really complicated roof layouts. I'm going to use this function even though I have a simple case here. So I'll select the roof generator. Again, I'm going to right click and switch over to add by walls, so I can do this in the 3D model by selecting the walls. We can also right click and choose if we're using rules based on truss framing or rafter framing. And the only difference is how it's going to calculate the height of the roof. If I select rafter, it opens up our roof parameters form where we can select which roof system we're going to use, the slope, how it's going to cut the fascia, and then how we're going to calculate the height of the roof. So in this case, I'm going to get the plate height from the 3D model, click the second floor wall, so that's giving me the height to the top of that second floor wall. We're also specifying an overhang, the seat cut, and it calculated the eave height based on these other values. So now I can click OK, select a wall that I'm going to add the roof to, then continue and select the walls around the perimeter, and confirm. The roof generator always defaults to a hip roof, but I can change that. If I select the roof, I can right click and change it to a gable. I'll just switch this back to hip and then convert this to a roof. So now we have tools for generating either rafter framing or a truss layout. I'll do a rafter by just selecting the roof planes and clicking generate parts. So now I have my roof frame and sheathing. We can select a sheet, Control A, and then hit H to hide all the sheathing. And so now we can see the framing. I can switch to the 2D layout now, go to the Output tab, and generate a schedule of our rafters. So I'll go to the Schedule function, select Rafters, and we're going to add labels, add a schedule, and we can even add part drawings if we want to create a drawing for each one of these rafter parts. So the part drawings we can get to from the document browser under Piece Drawings, and just double click on the part you want to look at. We can also collect the materials and generate reports. So first I will collect from the entire building, and in this case I'm going to select the wall panels accurate method, which means it's going to collect the framing pieces that we've actually generated. If you don't generate pieces, you can use this lineal foot method where it's going to estimate the framing based on the wall types, the length, the height, and number of windows. So now that it's just dumped all the materials into this database, I'll click OK, and then go to the report function and select a report that I want to generate. So we have a number of different cutting lists, either to text files or to Excel spreadsheets. And in this case, we can do wall framing by manufacturing order. I'll select all the panels. This report has the cut list ordered by the manufacturing order, indicating the stack number as well as its position within the stack. We also have reports that tell you the stock lumber, so you can specify the lengths of available lumber you have for the different species and grades, and it will look at your cut list and figure out how much of each length you need to purchase in order to have enough lumber for your cut list. It also does some optimizing to minimize your waste. If you want to see how it came up with that stock lumber list, you can run the minimum waste cutting report and see how much waste you're getting from each material. These reports are broken out by level, so this is our second floor, this one's our first floor, and up at the top you can see we have, these are the pre-cuts, so these are just giving us 0% scrap. If I scroll down a bit, here we can see I have 5 of these 8-footers, and I'm able to get all of these blocks out of one 8-footer, then these blocks out of the next, and so forth. And then we're left with 10% scrap. And down at the bottom, we get a summary for the entire level. Another useful report is our general bill of materials. If I run the Excel general bill of materials, Vertex is going to do some additional calculations and estimating some additional materials. This report includes any macros that you've added, doors and windows. It has the stock lumber list, as well as things that we didn't model, but it's estimating based on other quantities. So for example, if I look at the drywall section, it's looking at the square footage of the drywall layers of those walls and calculating how many 4x8 sheets it's going to need. It's also calculating joint compound, joint tape, primer, and screws, just using some simple formulas within the databases that you can go in and adjust. You can also add waste factors if you want to add certain percentages of quantities for individual materials. Thank you for watching this demo video. If you want to give this a shot yourself, go to argos.com and select free trial. When you're ready to go ahead with a license, you can click Buy Now, then select either a monthly or annual subscription. The features I've been showing are available in the advanced package. Click Add to Cart. If you want to send the information to an automated saw or wall panel line, you'll need the CNC Manufacturing Interface add-on. Then proceed to checkout and enter your payment information. Once complete, you'll receive an activation code and a link to download the installation package. Thanks again for joining.